of the surds. Now, the surds, we have questions like examples. Simplify. A 1 plus root 2 over root 3 minus root 2. B 1 over the 7th root of 2. And C x minus 1 over y over 3x plus 2y. Solution. The first one, rationalize, so we have 1 plus the root of 2, and then multiplied by root 3 plus the root of 2 over root 3 minus root 2 multiplied by root 3 plus root 2. That would be 1 by root 3, we have root 3 plus root 2 plus root 3. Root 2 times root 3, we get root 6. Root 2 times root 2, we get 2 over root 3 times root 3, we have 3. Root 3 times root 2, we have root 6 minus root 2 times root 3, we have root 6. Root 2 times root 2, we have 2. So together we get root 3 plus root 2 plus root 6 plus 2 over 3 minus 2, we get 1. So the solution is root 3 plus root 2 plus root 6 plus 2. Like that. And then for B, you write it as 1 over 2 to the power 1 over 7. And then subtract 1 over 7 from 1. You get 7 down. That will be 7 minus 1, giving us 6 over 7. So then when you come here, you multiply this by 2 to the power 6 over 7 down. In the numerator also by 2 to the power 6 over 7. So we get 2 or 6 over 7 over, when you add 1 over 7 plus 6 over 7, you get 1. So the answer down is just 2. So you pick the concept, yes?
Kindly repeat like question B.
So you get 1 over 7. So you get 1 over 7, the power of 2, and subtract it from 1 because you want to have 2 remain with the whole number as the power in the denominator. So you pick 1, subtract 1 over 7. The answer you get, you know that if you add it to 1 over 7, it will give you 1. That is the idea there. So that the power of 2 becomes 1. Then you have a child.
Okay. So,
Then,
sir,
yes,
so meaning if it was okay, 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 okay. Now I get. Thank you very much.
okay. So now we have x minus 1 over y be multiplied by root x minus root of 2y over root x plus root 2y be multiplied by root x minus root 2y. And then we'll have x times root x, that will be x root x minus x root 2y minus root x over y plus root 2y over y. Then divide everything by root x by root x to get x. And then the other one, they will cancel out. So you just do root 2y minus multiplied by minus 2y. So you get minus 2y. So we have rationalized. So easy. Yeah, whatever comes under rationalization. No trouble. Okay. Then you may also be asked questions like, I saw a nice question yesterday. 1 over 1 plus root 2, 1 minus root 3. For example, they ask you this question. Well, you can rationalize this question in so many ways. If you want, you first rationalize the second part. So you say, okay, I'll multiply the numerator by 1 plus root 3. So that I have 1 plus root 2, 1 minus root 3, multiplied by 1 plus root 3. So we'll get 1 plus root 3 over 1 plus root 2. And then here 1 by 1, we have 1 minus 3. So what we have now is 1 plus root 3 over 1 minus 3, that's minus 2, and then 1 plus root 3, I mean 1 plus root 2, multiplied by, rationalize now, 1 minus root 2. Also up 1 minus root 2. So we get, we expand 1 minus root 2 plus root 3 minus root 6 over minus 2. Then this is 1 minus 2. So we get 1 minus root 2 plus root 3 minus root 6 over negative 2 by negative 1, we get positive 2. So the idea is for you to stop rationalizing, you make sure that the denominator doesn't have a root. You get rid of all the roots. Like that. Like that. And then now we can talk about,
Sir,
hello.
I wanted to ask, what if you expand the denominator, then you rationalize it like the normal way?
You have issues because when you expand, you have, if you look at the numerator,
Okay, thank you.
okay? Then we go to irrational proofs. The questions that we expect here are questions like, one, given that root 2 is irrational, show that root 2 minus 3 is irrational. For example, so you say solution, let root 2 minus 3 be equal to a over b, where b is not 0, a, b are integers, and a, b are cofactors. That. Then you are saying, once I have this statement, the next thing to do is to make root 2 the subject. So you say root 2 is equal to a over b plus 3 over 1, which is b down, and then a plus 3b. Then you say, but the left-hand side is irrational, and the right-hand side is rational. And you say, which is a contradiction. Or whichever way, can we say which is not possible? So, root 2 minus 3 is irrational. This is what you have to write. Like that.
The example that you've given us is talking about, okay, it's like given that root 2 is irrational, meaning they've already told us that root 2 is irrational. Can you give us an example where it's not like they've not told us that it's irrational, but then they want us to prove that it's irrational?
That they want us to prove that this is irrational. without being told that root 2 is irrational. So for the sake of the quiz, remember last year how we marked this. If this part has been omitted, and then they ask you to prove that this is irrational, we went for this. That you still prove that this is the setup. So you still do it this way.
So
Even
like we can still prove it the same way you've done, even if it is not said that it is irrational.
yes.
Okay.
So whichever way it comes, whatever they mention to be irrational here, whatever they mention to be irrational here is what you make the subject when you start solving. Whatever this is, you can say root 32 minus 3. You extract from root 32, you extract the root 2. Other numbers will come out, and then you have written it like that. There should be root 2, make it the subject, and whatever you have, then you make this conclusion. Each time. Okay. I think there are not so many questions. And then the other concept is, of course, the concept of binary operations. Concept of binary operations. Whatever they give you for binary, let star be defined by A star B is equal to 2A 2AB. For example, on a set of real numbers. Then they say A is star commutative and or associative. B compute -1 star 0 star 3 and -1 star 0 star 3. Solution A is a star commutative. You want to check if A star B is the same thing as B star A. Now A star B is always given in the question. The job is to compute B star A. So we write as 2 to the power of BA, realizing that A and B are real numbers. You can say, oh, but this is the same thing as 2AB, which is A star B. Hence, star is commutative. For associative, you can even say, okay, I want to start with A. You compute -1 star 0 and star 3. To compute this, you get -1 star 0. Substitute there. So you have 2 to the power -1 times 0, which is 2 power 0, which is 1. So that -1 star 0 and star 3 becomes 1 star 3. So then you have 2 to the power 1 times 3, which is 2 to the power 3, which is 8. Okay? Then you also get -1 star 0 star 3, and say I want to start with 0 star 3. That is 2 or 0 times 3, which is 2, or 0, which is 1. And then -1 star 0 star 3 is going to be -1 star 1, which is 2, -1 by 1, giving us 2 power -1, which is 1 over 2. And then you say, if that is the case, well then, there you are done, you have done the computations. Then you say A, you are back to A, and say star is not associative. Because you have an example which fails to hold. This as star 3 is not equal to this as star 3. Because that is the definition of associativity. If the two are equal, then it is associative. But now they are not equal. So it's not associative. So because they will ask you to compute, so you can use the computation to check if it's associative. Because associativity then is a bit tricky because it involves the C. So the best here that I can advise now is always put numbers and check if they satisfy the property of associativity. Because the letters mostly confuse so many of us. So the best is if you can have a case that fails, then you're okay. Because if one case fails, then you can conclude. Where it's dangerous is to use this when commutative, because most questions are commutative. In an event where it's not commutative, you can use an example. But when it is commutative, you have to use an example. I hope that's what sense. On sets, you just need to know how to do the shading if they ask you to shade. If they ask you to simplify sets, simplify them. Set interval is a must. We just have to do that here. Just practice. Set intervals. Once more. Before you go for a quiz, you do set intervals. So at least we've touched every concept apart from the ones for set intervals, set simplification, set shading, which I believe we've done now. So I can safely say all the best. And you still have a lot of time to prepare. So you guys are busy that side, so this is the day that you need to use that. But again, after the quiz, you have maybe some good days of doing other stuff outside as you learn a bit the math, and then towards the test, again you have more intensity of them. right side, don't lose out on your progression that side. So that side is not for that time. Here in this case. Because now I just want to clear something. So